day 18 of 75, and this is the trick that turns impossible interview questions into 10 lines of Go. A problem asks for the minimum shipping speed, the fewest days, the smallest divisor, and your brain reaches for binary search, but there's no sorted array in sight. Here's the secret. The answer itself is the sorted array. Stick around, because once this clicks, 3 different LeetCode mediums collapse into one pattern. Picture this in plain English. You've got packages on a conveyor belt, each with a weight, and they must ship in order over a number of days. A ship has some weight capacity. Find the minimum capacity that gets everything shipped within D days. Pause and think about how you'd brute force it. You try capacity 1, then 2, then 3, checking each until 1 works. That linear scan is the slow version of the right idea. Now the insight. If capacity 15 works, does capacity 16 work? Obviously, more room never hurts. If 15 works, every number above it works too. That's monotonicity, and it means feasibility flips from no to yes exactly once across the range. A sorted Boolean line. False, 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 true, true. Binary search lives for exactly this shape. And the range is bounded. The smallest possible capacity is the heaviest single package because one item must fit. The largest you'd ever need is the sum of all weights. Ship everything in one day. Let's live code the predicate. In Go, func can ship weights, int, days, cap int, bool. One single pass slice scan. Need equals 1, cur equals 0. Range over weights. If cur plus w cap, start a new day. Need plus plus and cur equals w. Otherwise cur plus equals w. At the end, return need equals days. That's it. 8 lines, 1 loop, no allocations. This closure is the problem. Everything else is just plumbing around it. Now the plumbing, a generic search. Set low equals max, weights, and high equals sum, weights, both computed in 1 loop. Then, for low high, compute mid equals low plus high low slash 2. That form avoids integer overflow. If can ship weights, days, mid, the answer might be mid or smaller, so high equals mid. Otherwise mid is too small, so low equals mid plus 1. When the loop ends, low equals high, and that's your minimum. We use low high with high equals mid, not mid. 1, because mid could be the answer, we don't want to skip it. Trace it fast. Weights 1 through 5, 5 days. Low is 5, high is 15. Mid is 10. Can we ship in 5 days at capacity 10? Yes, easily, so high becomes 10. Mid is 7. Yes again, high is 7. Mid is 6. Still yes, high is 6. Mid is 5. Now we need more days than 5, so low becomes 6. Loop ends. Answer is 6. Logarithmic steps instead of scanning every capacity. That's the whole machine. Here's the payoff. Coco eating bananas. LeetCode 875. Minimum eating speed to finish all piles in H hours. Same scaffold. Change only the predicate. Func can finish piles, int, h, speed int, bool. Sum up, pile plus speed. 1/speed for each pile. That's integer ceiling division. No float 64. No rounding bugs that sink Python solutions. Return hours equals h. Search speed in 1 to max pile. The search loop doesn't change 1 character. Swap the closure, swap the problem. Cheat sheet. 3 predicate signatures share 1 shape. Can do, mid-int, bool returning monotonic yes/no. For shipping and book allocation, your upper bound is the sum. For speed and divisor problems, it's the max element. The one bug that bites everyone. Low equals high versus low high. Use low high with high equals mid when you're hunting the boundary value itself. Write the predicate first, search second, always. Day 18 done. The answer space is sorted even when the input isn't. Subscribe for day 19.